Hello dear friends, myself Sonigra, and today we are going to discuss about detail and assembly drawing with some typical examples, the solutions and use of detailed drawing and assembly drawing in industrial applications. And today's objectives for present discussion includes to draw detailed drawing from given assembly drawing, to prepare bill of materials and solution of typical problems. We will cover the discussions related to these aspects with some live examples. Now, what is assembly and detailed drawings? So there are several different types of engineering drawings, that is detailed drawings, or it is also called as single part drawing because it includes details of a single part. Assembly drawing, it could be said as multi-part drawing because more number of parts are included in assembly drawing. They are assembled together and drawing is drawn. Then third one is collective part drawing. Then fourth one, combined detail and assembly drawing. In some cases it's needed to draw the drawings having combination of detail and assembly. In assembly drawing, some details are included like some dimensions, some materials, sectional lines and so on. And the last one, that is exploded drawing assembly. That exploded drawing assembly shows the relative position of each parts with each other if they are moved at certain distance from its original place. In detailed drawing, it is used as the main reference in the manufacturing of individual components. If you want to manufacture individual parts, the detailed drawings are necessary. With the help of assembly drawing, manufacturing would be difficult because in assembly drawing the details are not included. In a detailed drawing, the details like the part number, part material, the manufacturing process, surface roughness, its dimensions, all data are mentioned in the detailed drawing. Hence, it is used as the reference to manufacture individual components. The detailed drawing should give complete detailed information to manufacture the component. It should completely define the shape and the size of the product. It includes all the dimensions and tolerances. Whichever tolerances are designed, they should be written with standard notation, and the detailed drawing should include information related to material, treatments or any heat treatment, requirement of the surface finish, inspection, etc. All these things are to be shown on the detailed drawing of the objects. Now we will see one animation related to submersible pump assembly drawing. How to prepare assembly drawing of a submersible pump, how they are assembled together, and this is also there in the syllabus of our subject mechanical drafting, how to draw the details and assembly of the submersible pump. So for this submersible pump, let me see its basic working principle. This is the submersible pump assembly having nuts, bolts and base. You can see here, this is the shaft which is assembled together, and these are three views of this pump. Let me again check it. This is the disassembly of the submersible pump. These are the components. As you can see, 5 components are there. One is pump body, then pump casing, impeller and pump bushing and bearing, and lastly nuts and bolts to assemble it together. So this is the standard drawing of submersible pump. Now this is the detailed drawing which is drawn with the third angle projection method, and it is a typical pipe bend. The pipe bend is used to connect two pipes which are at a right angle to each other. Here all the dimensions are shown with the details. You can see here radius 40, radius 70, circularity 0.2 with M is shown over here. Circularity 0.2 means the diameter difference measured at any two instant, or we can say diameter difference along its vertical diameter and horizontal diameter should not be deviate from more than 0.2 millimeter or 200 micron. It is the meaning of this symbol. Here 4 holes are there, 4 holes of M12 spaced as shown. So here 4 holes are there, they are spaced at given distances, that is 30 plus 30 60 mm. These are the dimensions, and here 0.5 is written, 0.5, and this symbol is drawn. This is the symbol to show the parallelism of this surface. It means that this surface, this one which is shown over here, it should be parallel to this surface, and the deviation for parallelism is allowed up to 0.5 millimeter or 500 micron. If that deviation is more than 0.5 millimeter, it is not allowed. Either it should be reworked or reproduced, or it could be rejected. And this symbol, this is the symbol to show the perpendicularity of this surface with respect to the reference surface A. Perpendicularity 0.5 millimeter with respect to surface A. So this is surface A, and perpendicularity of this surface, this one, this surface with respect to this surface should be 0.5 millimeter. So with this detailed drawing we can use the details like all the dimensions, perpendicularity, parallelism, circularity, radius, diameter, various arcs, as well as this section line. This section line indicates that it's a hollow cylindrical shape, and section line shows that if we cut this object along this line, here material will be cut, and it shows the section AA, which is written over here. A starts from here, it moves to here and up to this one. This is section AA, and this is sectional AA sectional view. Now here name of component is written, that is pipe bend. Here name of company is mentioned. I am thankful to this Newstone Engineering to provide this drawing to me. Here the details like issue date, issue number, here issue number, issue date, drawing number, etc. are mentioned over here. Here drawn by the person who has drawn this, the date of drawing. Then here some other details related to this drawing are written over here. For example, all dimensions are in millimeter, tolerances on linear dimensions to be this one DS unless stated otherwise, tolerances on and ES or AS. These tolerances are used in this drawing, and here the drawing number is written in reverse order. You can see here in reverse, because if you fold this sheet in such a way that this will come in forward direction, and in the first page we can see this in appropriate place. So this is provided to have proper folding of the drawing. Now assembly drawing, where assembly drawing is used and what's its importance. The assembly drawing is used to show how a number of components are fitted together to make a complete product unit, how they should be placed together to prepare a complete product. It will have the minimum information such as overall size. Individual sizes are not mentioned in the assembly drawing, and overall dimensions may be shown in the drawing. Even it is not compulsory to show overall dimension as well. Each individual components is referenced by a number in a circle, or it is also called as balloon reference, and a leader pointing to it. Numbers are given in the assembly drawing. For example, number 1, 2, 3, 4 and so on, and all the numbers are named in the part list. So everywhere it's not compulsory to write the name of part. The name of part is mentioned in the parts list, or it is also called as bill of material. Part list table is indicated on the drawing to the left side as shown over here. This is one typical assembly drawing of machine wise assembly. You can see here these are the number of component written over here. Number 1, the number 1 is the body, which is this is the part list or bill of material, and in part list number 1 is written body, so this is body. Number 2 is this one, that is a moving jaw. This jaw is moving jaw, that is number 2. Number 3 is this one, which is screw, this one, it could be rotated. Number 4 is jaws, this is jaws, 2 jaws are there to provide proper clamping. Number 5 is a plate, locking plate. With the help of this plate we can lock this assembly. Number 6 is this one, it's a special washer which is provided over here to prevent the movement of this corrosion or erosion between this nut and this surface of this jaw. Then nut, number 7 is the nut. Number 8 is also screw, this one, this is the screw, and number 9 is also a screw, this is screw. So this is the assembly of machine wise, and this is typical assembly drawing of machine wise. You can see here AA is written, that is section AA is here, and this is the sectional view of section AA, and here first angle projection method is employed. So this is the front view and this is the top view, and it's a sectional front view of given top view of this machine wise assembly. This problem may be asked in examination to draw assembly drawing from given details. So detailed drawings of all these 9 components would be given to you, and from those detailed drawings you have to assemble all the components, and after assembling it will appear as shown over here. Or the question may be asked in reverse, like this data is given to you, assembly drawing is given to you, and you have to disassemble and you have to draw the detailed drawing of each component individually. So in that case you have to draw any 2 views of the component, either front view and top view or front view and side view. Generally in all the components front view is necessary to show its internal details and all related details and dimensions of the product. Here also I am thankful to this Newstone company to provide me this drawing. This is the serial number M135, issue number, issue date, and here some special remark is shown, that is the drawing is the property of the company and it could not be copied to anywhere, but it could be used for study purpose only. Because here dimensions are not mentioned, it will not violate any rules and laws related to the company. And this is the part list, or it is also called as the bill of material. And this is the older drawing, hence this part list is written from here 1 2 3 onwards, but in the latest drawings and in some revised drawings this part list is drawn over here. That we also will see in the subsequent slides, that this part list is prepared in the reverse manner. Serial number is written over here, 1 2 3 4 onwards are written in reverse order. Now collective part drawings. What do you mean by collective part drawings? It's an alternative to single part drawing. We can use in place of single part drawing. It shows an item with all dimensions, but those dimensions which vary will be given a letter, and by reference to a table the size or sizes and the part number can be obtained. So that is called as the collective part drawing. In collective part drawing, dimensions are not inserted in the drawing, but some letters are inserted. For example, in place of diameter, D would be written. In case of length, L could be written. In case of thickness, T could be written, and all these parameters, say L, D, T, etc. are variables. It could be as per the shape or standards name of the component, its sizes vary, and according to this D, T, L and all these parameters, a table is drawn in the drawing, and in that table the specifications are mentioned. For example, if size is say M12, then according diameter D value would be given in the drawing that it's a 12 millimeter, and accordingly its thickness, its length, its threads, etc. all these parameters are shown in the table. For example, in case of rivets, nuts, bolts or any standard parts, all these parts are drawn with the help of collective part drawings. The items have the same form, but the dimensions may vary. Its shape and form remains the same, just the dimensions varies. This is an example of collective part drawing. It could be seen here. Here 5 are written, 5 and length. So this length is say L, and if these are the standards of the product, for example, let me pick up one S251210. It means that if this is the specification, this length would be 10 millimeter as shown over here. If the part name is S2512-12, then this length will be 12 millimeter. If 14 S251214, then this length would be 14 millimeter, and so on. So this here, with the help of only one drawing as drawn over here, we can draw n number of drawings. For example, here 1, 2, 3, 4, 5, 6, 7 and 8. 8 part names are written. So it's not needed to draw 8 components. Only with the help of one drawing we can express and we can show 8 different drawings of this product. Here also name of company, name of the product, that is rivet, is shown over here at the bottom. Here title block is shown, serial number, date of the drawing is shown in the title block. Some special instructions are written over here. Say for example, all dimensions of these tolerances are in millimeter. Here the S2512 is written in reverse order,